Hello, everyone. Welcome to this webinar. Apologies for the delays. There's been some issues with the BrightTalk platform that we faced, but hopefully we're all set now and we'll still be able to go through the webinar content. My name is Titus Kurek. I'm a product manager here at Canonical, mostly focused on the data center part of our business, including server and OpenStack. And today I'm going to present you an intro to OpenStack and how open source private clouds are changing the game. There's no special knowledge required in order to prepare for this webinar. This is a high-level intro to OpenStack, so don't feel afraid to participate and ask any questions that you may have. We're going to have a dedicated Q&A part at the end of the webinar, but if you raise your questions early, we'll hopefully be able to prioritize them. So on that note, let me also thank our partners who helped us organize this event, Canonical partners with various organizations all over the world to make sure that our mission is fulfilled well, and our mission is to bring the power of open source to everyone on the planet, starting from big enterprises up to individuals. So now very quickly, since we've already lost like 20 minutes, we're going to navigate through the following topics. We'll start with an overview of the origins of OpenStack and how did it evolve. So from grid computing to OpenStack. Then we'll attempt to answer two fundamental questions. So first of all, what is OpenStack? And even more importantly, why OpenStack? Why not any other cloud platform? We'll go briefly through the architecture principles and some basic terms that are usually used when talking about OpenStack and its resources that it allows to be created. Then we'll cover briefly OpenStack services and their functions, and the presentation will follow with a brief demo showing an OpenStack in action, and you can actually repeat all of those steps from the demo on your workstation as we'll demonstrate. And finally, we'll wrap up the webinar with some key takeaways, and we'll open this interactive Q&A part. So OpenStack has its origins in the grid computing paradigm, and then it evolved as the cloud computing paradigm has been progressing. So let's now briefly have a look at the evolution of OpenStack and how did it evolve towards the most mature, the most popular open source cloud platform that is now being used in many production environments all over the world. So I'm going to start with showing you the picture of Mr. Thomas Watson, the head of IBM, who in 1943 said a very interesting sentence, so that he thinks there is a world market for maybe 5 computers, right? It sounds really funny nowadays. I think all of us are sitting in front of computers right now. And there's obviously BrightTalk streaming service that also runs on some computers over there in the internet. There are public clouds, there are data centers, and I'm pretty sure, I don't know the exact numbers, but I'm pretty sure that we actually have more than 5 million of computers on the world right now, or even 5 billion. And taking into account like all virtual machines, all containers, or serverless workloads that are running out there, I think there may be even more than 5 trillion of computers, right? So this is really interesting, but this is how it all started. Like it started with isolated computers that were not able to communicate. In 1990, the origins of grid computing paradigm, like in 1919, people started talking about grid computing as a paradigm that would allow computers to connect over network and share resources so that those could be kind of grouped together and aggregated into bigger pools. And this is how it all started. In 1997, the distributed.NET platform has been launched, and it's still available, that allowed people to basically share their resources over the internet. So I could connect over there, you could connect over there, and we could share our compute resources on our computers. In around 2000, the cloud computing paradigm has started getting momentum, and people started kind of formalizing how cloud computing is going to look like, and it evolved from grid computing, but introduced a lot of different terms and principles around the cloud computing architecture. And then in 2006, the AWS EC2 platform was first launched. So AWS EC2 is obviously the most popular commercial cloud platform. It was initially launched as a public cloud only, and being the first on the market, it kind of dominated the market, right? So it still owns the biggest portion of the cloud revenue and is the most popular public cloud platform. But then 4 years later, the OpenStack project was first launched in response to AWS EC2. And initially, OpenStack was mostly launched as a kind of an open source implementation of the AWS EC2 service. So it obviously evolved later on according to the needs of the community and commercial adopters. But it still resembles the behavior of leading public cloud. So whatever you can get from AWS, you will likely be able to get from OpenStack as well. OpenStack was originally launched as a project between NASA and Rackspace, but it was later transitioned under the governance of the Open Infrastructure Foundation, initially called the OpenStack Foundation. 2014, Canonical launched its own OpenStack distribution, a commercial distribution of OpenStack, providing consulting, support, and fully managed services to enterprises. And well, we're in 2021. So over those 11 years since OpenStack was first launched, there's been an explosive growth of OpenStack as reported by the Open Infrastructure Foundation. According to the OpenStack user survey result from 2021, there are more than 25 million of cores running in production all over the world across various organizations, various market sectors, and OpenStack has been basically constantly growing. When talking about OpenStack, it is important to differentiate it from the traditional virtualization management platforms such as VMware, because they evolved independently of each other. And while OpenStack, again, resembles the behavior of leading public clouds, traditional virtualization platforms might not. So first, talking about the TCO, it is total cost of ownership. It's usually high in those traditional platforms because of the license cost, while in OpenStack, it is relatively low thanks to the open source nature of OpenStack. The resource management is based on those pets and cattle accordingly. So in traditional platforms, VMs run in isolation, they're curated, they are maintained individually, while in OpenStack, VMs can be deployed and terminated constantly. So it's more like a cattle approach, the one used by the leading public clouds. On the resource provisioning front, with traditional platforms, it's image-based, while in OpenStack, it's template-based. And we're going to talk about that a little bit more later when we talk about the OpenStack architecture. The hardware being used in traditional virtualization management platforms is usually specialized. There are a lot of blades and disk arrays running over there in production, while in OpenStack, it's usually a commodity hardware. At least it's designed to run on the top of a commodity hardware. Traditional platforms scale up. So if you lack resources, you have to add more RAM, you have to add more disks, while in OpenStack, you have to add more nodes, right? It scales out. The workloads running on top of traditional platforms are usually stateful, while in OpenStack, OpenStack allows them to be designed in a cloud-native fashion so that they're stateless. And last but not least, open source. Traditional platforms are usually not open source, and OpenStack is 100% open source. If you are wondering how to get started with OpenStack on Ubuntu, there are two approaches you can take. So first one is called MicroStack. MicroStack is an opinionated OpenStack that provides a straightforward installation instructions. It's really lightweight, allowing to run even on your workstation. You don't necessarily have to set up like a big cluster or whatever. You can run a single node MicroStack installation on your workstation. And it provides an on-Rails experience so that you can actually get started with it in 2 commands, and the entire installation process takes around 20 minutes. While moving into more decent environments, like production environments, there's Charmed OpenStack, which is more like a composable OpenStack that provides various configurations, variations, lifecycle management capabilities, and can be deployed at any scale. So if you want to get started, use MicroStack. If you want to evolve your environment, consider moving to Charmed OpenStack. But let's step back. What is OpenStack and why OpenStack over any other cloud platforms? Let's spend some time discussing that. So first of all, OpenStack is an open source cloud platform, just like Linux is an open source operating system, right? So you probably have an experience with various operating systems such as Linux, Windows, Mac OS X. Some of them are proprietary, some of them are open source, right? Linux is the most popular open source operating system. And it's the same for OpenStack. Like there are various cloud platforms available out there. There's AWS, there's Azure, there's Google, there's Oracle Cloud, there's VMware. OpenStack is an open source cloud platform, and at the same time is the most popular cloud platform. Let's have a look at the following chart. So this chart that's provided by statista.com actually outlines the evolution of the adoption of various cloud platforms and how it was changing over the years. So you have a look at this green line. This is OpenStack, and its adoption has been constantly increasing over the last couple of years. While having a look at VMware, for example, we can see that its adoption has started decreasing recently, right? So OpenStack is the most popular open source cloud platform, and its adoption has been increasing constantly. Let's also have a look at the OpenStack in numbers. So according to the Open Infrastructure Foundation, OpenStack is one of the 3 mostly developed open source projects all over the world, and only 3 projects achieve this level of contribution, and those include OpenStack, Linux kernel, and Chromium. There are more than 25 million of cores running in production, and during the last year, more than 100 new production clouds have been deployed by various organizations all over the world. And last but not least, according to the latest results from the OpenStack user survey, Ubuntu is the most popular operating system for OpenStack deployments. It powers around 40% of OpenStack clouds all over the world. So when people think about OpenStack, they usually think about Ubuntu as the underlying operating system for cloud infrastructure deployment. Having a look at the companies involved in OpenStack, and this is a really big ecosystem and a big community. There are companies coming from various market sectors. So there are obviously OpenStack vendors such as Canonical or Red Hat, Mirantis. There's Rackspace, which was the one of the founding companies of OpenStack. But there are also hardware manufacturers such as HPE, Huawei. There's Intel, who put a lot of investment in OpenStack. VMware has its own OpenStack distribution as well, even though they promote the vRealize suite as the first-class solution for virtualization management. There's AT&T, who invested a lot in OpenStack, and AT&T is obviously like the biggest telco in the US. So choosing to develop your career in OpenStack gives you an opportunity to work with all of those exciting companies all over the world. And finally, having a look at the community itself, OpenStack has its own community governed by the Open Infrastructure Foundation. It includes around 450 organizations from various parts of the world, and again, various market sectors, and more than 8,500 developers ever contributed to OpenStack. I'm proud to be one of them, and you can be one of them as well, since OpenStack provides a very nice developer's guide for newbies. So if you want to get started with OpenStack and start contributing, there's a dedicated developer's guide that you can follow and start solving basic bugs or in introducing some exciting features. There's also an admin's guide that's available for sysadmins, and even more interestingly, there's a bunch of industry events organized by the OpenStack community, with the Open Infra Summit being the leading one, and OpenStack project team gathering meetings taking place like every 6 months ahead of the upcoming OpenStack releases. So let's now focus a little bit more about why OpenStack, why not VMware, why not public clouds, and why just OpenStack? Why are companies choosing OpenStack? So OpenStack ensures maximum cost optimization. And this may not be relevant for like a regular engineer, but this is very much relevant for the business owners. It is very much relevant for the heads of the infrastructure departments who have their dedicated budget for running their infrastructure and have to make careful decisions where the organization's workloads are going to run. So OpenStack ensures this maximum cost optimization. And let's have a look at the following quote that we got from one of our customers, SBIB. This is a quote from Georgi Georgiev, who's the CIO at SBIB. So he said that Canonical solution was a third of the price of the other proposals we received. The solution is also proving to be highly cost effective, both from Capex and Opex perspective. We'll talk about that in a little bit more details in a minute, but let's just have a look at that again. Like, this is really the reason why companies are choosing OpenStack. It helps to optimize costs. It proves to be cost effective and it's basically cheaper than public clouds and dedicated virtualization management platforms. So let's talk a little bit more about those Capex and Opex costs and how do they shape in public clouds and private clouds. So first of all, let's have a look at the Capex costs. And Capex costs are like the capital expenditures. Those are the costs organizations have to pay upfront when making an investment. In public clouds, the Capex cost is relatively low because if you think about it, all you need to do is to set up an account on AWS, for example, attach your credit card, and you can start using cloud resources, right? You don't really need to make an investment, right? But when you build your own private cloud on-prem, There's a hardware that you need to purchase. This hardware needs to be racked and cabled. And at the end of the day, you have to pay for the cloud delivery services as well. On the other hand, having a look at the OpEx costs, this is how they shape when comparing public clouds to private clouds. So in public clouds, the OpEx costs, the recurring costs, grow very fast as the number of workloads grows over time. While when in a private cloud, those costs are relatively static and lower compared to public clouds. Now, if we put those two costs together, we get the total cost of ownership, so Capex plus Opex, and this is how it shapes more or less in public clouds compared to private clouds. Putting those two on the same chart, we get the following. So obviously, at a small scale, public clouds are the preferred approach because it doesn't make sense to build a dedicated private cloud platform for, let's say, 10 virtual machines, right? It is just cheaper to run them in a private cloud. But once the number of workloads grows, once they are running 24/7, 7 days a week, and so on, the hybrid or a multi-cloud approach might be preferred. So at some point, it basically makes sense to build your own data center to move the majority of your workloads over there, and only use the highly scalable public cloud resources occasionally, like during heavy load periods or when running compute-intensive operations occasionally. This is why organizations choose to use private cloud to build their own private cloud infrastructure, like not just continue to use public clouds only. So now very briefly about the architecture principles and basic terms when in the OpenStack world. It consists, so first of all, OpenStack has a modular architecture. It consists of a variety of interconnected components that are responsible for certain operations. So first of all, there are OpenStack services which handle basic cloud functions and expose API endpoints so that client can interact with them. There's an OpenStack dashboard that provides a web-based user interface to the OpenStack cloud, as well as there is an OpenStack client which provides a command line interface. All OpenStack records are stored in the SQL databases, and there's also a message broker that facilitates inter-process communication for processes inside of a single OpenStack service. And in more advanced environments, there are like additional components such as NoSQL databases, Memcache, etc., that are used for specific functions. And now on the terminology, you probably know this statement, so that when in Rome, do as the Romans do. So, well, when in OpenStack, make sure you speak as the OpenStackers speak. So a tenant is like a user or a group of users with isolated cloud resources. So OpenStack is a multi-tenant environment. Various organizations can use a single OpenStack cloud at the same time, and they have no knowledge of each other as the resources are fully isolated. An image and the flavor are templates used for instances provisioning process, whereas the instance is just a virtual machine provision from the image and the flavor. By default, instances have an ephemeral storage attached, which is like a volatile storage attached to the instance. But you can also create block storage devices, which are again attached to the instance but are non-volatile. And object storage is a cloud-native, non-volatile storage that's accessible through the APIs. So it's more like available for the applications. And last but not least, security group is a virtual firewall attached to the instance. So now let's talk a little bit more about the OpenStack services and their functions. So there are 5 primary services that are available in OpenStack. And those include Keystone, which is the OpenStack's identity service that provides authentication and authorization functions. It also manages various cloud records such as domains, projects, roles, groups, and user accounts, which at the end of the day allow OpenStack to be set up as a multi-tenant environment so that it can be shared by various tenants. Keystone integrates with LDAP, Active Directory, SAM, and any other external identity mechanisms, and is a kind of a must to have service in OpenStack, like all other services are dependent on Keystone. Glance is the OpenStack image service, which primary function is to manage the catalog of cloud images. So let's say if you want to provision Ubuntu instances, you have to upload an Ubuntu image to Glance. If you want to provision an CentOS instances, you have to upload the CentOS image to Glance. And it can also build and validate images depending on specific requirements. So it has its additional functions. The OpenStack Nova service is the essential service that provides the compute capabilities. It basically manages distributed compute resources and is responsible for instance provisioning, scheduling, and termination. So when you provision an instance in OpenStack, it finds the hypervisor where the instance will be provisioned and uses KVM or any other hypervisor underneath to actually launch the instance. So Nova does not provide, is not a hypervisor on its own. It rather wraps around the existing hypervisor and provides those on-demand provisioning capabilities. And Nova also manages the ephemeral storage devices, so those are created by Nova. Neutron, on the other hand, is the network service in OpenStack that, again, wraps around the existing SDN platforms, such as Open Virtual Network or Open vSwitch, or any other SDN platforms such as Juniper Contrail or Cisco ACI, and basically creates virtual network resources such as networks, subnets, routers, and security groups. And finally, Cinder is the OpenStack's block storage service that enables creation of non-volatile block storage volumes and also allows them to be snapshotted and backed Cinder, again, does not provide those services on its own, but rather wraps around the existing storage platforms. Ceph is the most common software-defined storage platform used in OpenStack deployments, but Cinder also works with LVM, NetApp, Pure Storage, etc. And finally, there are more and more OpenStack services that are available out there that provide various functions. So if you think about AWS EC2 again, like you get an option to launch containers over there, you get an option to launch serverless workloads, and it's not any different with OpenStack. So there are more and more projects being created every year that provide various functions and are kind of external to those core services provided by OpenStack, but also available. And now we're going to do a short demo, and because of bandwidth limitations, I had to pre-record it. So we're going to start with the MicroStack installation on a dedicated computer. MicroStack, again, is the opinionated OpenStack that provides the most straightforward installation instructions to get started with OpenStack on Ubuntu. MicroStack is available as a snap, which means all OpenStack services and their dependencies are packaged together in a single image that runs in isolation, providing better security. The entire process takes just 2 steps. So we have to install MicroStack, which is what we're doing here. This command takes around 2 minutes, depending on your bandwidth. It has to download the entire microstack snap from the snap store, which can take some time depending on your bandwidth. And there are 2 flags that we have to pass to this command at the moment. So it got installed. As you can see, the version of OpenStack that got installed with this version of a microstack snap is Usuri. And now in the next step, we're going to initialize microstack. We're going to initialize it in the all-in-one mode. So basically all services running on a single machine. And this command takes around 20 minutes, right? So we're not going to wait until it finishes. Instead, we're going to switch to a different computer where microstack has already been successfully installed. And here we go. This is how the output of the installation and initialization command looks like. So once this is done, again, 2 commands around 20 minutes, we have fully operational OpenStack up and running, and we can start launching VMs. So in the next step, we're going to launch a sample VM called test. We're going to use the 0s image for instance provisioning purposes. 0s is like a lightweight Linux image that can be used exactly for this purpose, like for testing whether the cloud has been deployed successfully. The provisioning is relatively quick because of the image size, which is very small. So once the instance is launched, we can SSH to this instance, and we get a command that we can use for this purpose. So let's just copy paste this command. Too quick, the instance haven't opened the SSH port yet. So let's try again in a couple of seconds. And now we get there, like we're inside of the instance, right? Like that's the instance running on OpenStack on my laptop. We can execute some regular Linux commands. As you can see, its uptime is really 0 minutes because it's just been launched. So that's pretty much it. We can exit from the instance, and in the next step, we'll explore the OpenStack dashboard a little bit more. So for this purpose, what I'm going to do is I'm going to obtain the credentials for the OpenStack admin user that we use to interact with the OpenStack cloud. And this is the command that allows us to obtain those credentials. So we can copy the password and use it when logging to the OpenStack dashboard. In order to get to the OpenStack dashboard, we have to open the web browser and move to 10.20.20.1, if I recall correctly. Let's see. Here we go. Yes. So that's the IP address that microstack listens on by default. So the username is admin. The password is the one that we copied from in the previous step. So we're just going to paste it. Yeah, let's check whether this is exactly this password. It is. So we can sign into the OpenStack dashboard, and this is how the OpenStack dashboard looks like, right? We can see that one instance is already running there. This is this test instance that we launched in some previous steps. What we're going to do right now, we're going to download the OpenStack RC file that is required for the OpenStack client to be able to connect to the OpenStack cloud. And this RC file contains a bunch of environmental variables. We can display the output of this file. So yeah, it really exports the environmental variables that are required to interact with the OpenStack cloud. We have to source this file, and again, we have to paste the password of the admin user. And now we can use the OpenStack client to interact with the OpenStack cloud. Since microstack uses the self-signed certificate, we have to pass this insecure flag over here, and we can execute typical OpenStack commands to interact with the cloud. Like here we listed the endpoints that OpenStack services are listening on. Now, getting back to the OpenStack dashboard, we're going to see where we can create various records managed by various services, starting with the Keystone service. So Keystone manages various types of resources, starting with roles. There are 3 roles created by default in MicroStack, admin, member, and reader. We don't have to change them, but roles basically define what users and group can do. There are 6 users created by default, like each for the OpenStack service, and there's the admin user we've been using so far. We can create additional users and set passwords for them so that various users from our organizations can use OpenStack. We can also group them into groups. And then the concept of projects, again, isolated resources available to dedicated users or a group of users. We have the admin project created by default and the service project created for OpenStack services. But if we really want to enable multi-tenancy, we have to create new projects and assign proper roles for users and groups. Now, moving to the Glance service, there's a CROS image created over here, as we can see, that we use for the purpose of our 10th instance provisioning. But we can also create new images using the Create Image button on the right. So that's mostly it for the Glance. We're now going to move to the records managed by Nova. So under Project Compute Instances, we're going to see our OpenStack instance that we launched in the previous steps. The test instance, as you can see, it was launched from the CROS image. It has some IP addresses assigned, a flavor defined. We can launch instances using the Launch Instance button, and there's like a big menu over here that you can fill in to customize your instance for provisioning. And now moving to the resources managed by the Neutron service, we're going to switch to project network topology, where we're going to see like 2 networks and 2 subnets. There's an external network that provides connection to the rest of the world, and there's a test network that's an internal network available to OpenStack only. Those are interconnected with a virtual router so that you can see this router here. It has interfaces attached to those 2 networks. And there is a test instance available over here that's attached to the test network and the test subnet. And finally, moving to the resources managed by the Cinder service, project volumes. As you can see, there are no volumes created yet because we didn't create any during the test instance scheduling process. So that's pretty much it in terms of the demo. So if you want to try MicroStack, well, if you want to try OpenStack yourself, then first of all, you can get MicroStack from MicroStack.run. And again, just 2 commands and 20 minutes to get started. If you'd be looking for more advanced setup, like a multi-node MicroStack installation or charmed OpenStack basic cluster, then you can refer to the install page at ubuntu.com/openstack/install. And the new page that is coming, it's not available yet, but will be soon available on our website, ubuntu.com/openstack/tutorials, with a set of tutorials for the beginners that you can use to get started with OpenStack on Ubuntu. And just to briefly recap some takeaways, OpenStack is the most popular open source cloud platform, and its adoption continues to grow. It provides better economics than hyperscalers and VMware, and this is why it's being used as a cloud platform by many organizations all over the world. It has a modular architecture that resembles the behavior of leading public clouds. And again, you can get started with OpenStack quickly using MicroStack. So that's mostly it in terms of the questions, that in terms of the content, but I'd be more than happy to answer any questions that you may have. So thank you very much for watching the show. So far, there are no questions in a QE, but we're going to wait until the end of the hour so that you may still have an opportunity to ask questions. Is the microstack beta still? Yes, it is, but we're taking significant investments around microstack, and we're going to evolve it towards a real fully stable production environment. But at the moment, it's considered beta. Some functionalities might still be limited, but if you have a specific use case, I'd encourage you to stay in touch with us and get in touch with us for more details. Is the microstack recommended for production purposes? Again, it falls back again into the same topic. Not at the moment, but we're taking steps to make it available for production environments at some point. At the time, for now, if you want to install OpenStack on Ubuntu, Charmed OpenStack is the recommended solution for production environments. Where is the difference between a container management solution like Kubernetes and a cloud platform like OpenStack? Is that when you're using Kubernetes, you need to connect all the different systems yourself. So interestingly, Kubernetes works very well when deployed on top of OpenStack. It can obviously run on bare metal as well, but it deploys easily on top of OpenStack. And with this approach, you basically get two platforms, like the one that provides VMs on demand and the one that provides containers on demand, running on the top of the same infrastructure. So this is really interesting. How to download the OpenStack VM images? Well, I'm not sure about the other operating systems, but if you go to Google and type like Ubuntu Cloud Images, you'll find a repository of Ubuntu images that you can use to provision instances on OpenStack. There's a question about will microstack continue to be open source? Yes, it will. Can Charmed OpenStack be deployed in air-gapped environments? Yes, it can. It provides this functionality. So yes. Microstack wide dev mode. This is because of some legacy dependencies on snapd running in a strictly confined mode. So there's been some progress on the engineering end to make microstack a strictly confined snap. So it soon will be available without the dev mode, but until the new version of snapd is released, it still has to be installed in the dev mode. We're over time, and I would like to apologize one more time for the fact that we started late. We'll take actions to investigate what happened, but we really need to wrap the webinar now since we're running out of time. So I'd suggest that you continue stay in touch with us, and any other questions you have, you ask through the discourse, through our official channels. If you go to microstack.run, you're going to find a link to where to ask questions and get some help from the community. So I'd encourage you to get in touch with us over there and continue your journey with OpenStack on Ubuntu. But on that note, we really need to wrap, as this event will end anyway in a couple of seconds because of the BrightTalk limitation. So one more time, thank you very much for watching this webinar, and let's stay in touch, and wish you a lot of success on your OpenStack journey. Thank you.